Hi everyone, I'm Dr. Lemieux and I will be teaching Chem 205 Quantitative Analysis next semester in spring 2026. I made this video to spark your interest in the course. This will be a hybrid course where lecture will be held asynchronously via online videos and assignments in lab will be on Tuesday and Thursday mornings from 8 to 11 a.m. Quantitative analysis is a part of a subdiscipline called analytical chemistry. This branch of chemistry involves performing experiments and using chemical methods and instrumentation in order to quantitatively determine how much of something is in a sample. I know, super cool, right? This course was originally designed and taught for many years by our resident analytical chemistry expert, Dr. Sherry Lillard. I'm teaching this course this semester, and I will be very happy to be guiding you through this journey to hone your analytical lab skills and learn about cool new instrumentation should you choose to enroll. We'll learn the theory and calculations in lecture, focused on the information that we need to perform reproducible experiments. And as expected, we'll actually do the experimental work in the lab. We will also spend quite a bit of time analyzing our data, usually with Excel. If you're new to Excel, no worries. There's a lab assignment that teaches you how to use Excel for the types of calculations and plots that we'll see in this course. These skills will also give you some insight into programming, which you may find useful in a variety of other fields. All parts of this class, lecture, lab, and data analysis, are designed to help reduce uncertainty and improve reproducibility of your measurements so that your results have better accuracy and higher precision. I'll give you a few examples of some of the things we'll do. Gravimetry. Gravimetry is a fancy term you probably haven't heard before, but it's a method where we perform precipitation reactions and measure the mass of the product. It doesn't sound too difficult, but the technique is all about getting a good quality precipitate and taking careful mass measurements along the way. Titrations. I know what you're thinking. You're thinking how you light up with joy when you see a titration problem. Me too. One of the titration experiments we will do is to determine the hardness of tap water. There's a chemical reaction followed by titrations where we quantitate how much calcium and magnesium are in the sample. Another experiment we do is a redox titration to determine vitamin C content in a sample. For absorbance, think Beer's law, we'll learn more in detail in lecture about the absorbance process and how instrumentation works to take the measurements. In lab, we'll do 2 or 3 absorbance experiments. One of them will be to determine the beta-carotene content in carrots or supplements. Another instrumental method we'll study is high-performance liquid chromatography, or HPLC. In the lab, examples include analyzing a drink sample for its caffeine content or determining the capsaicin concentration in a sample of peppers or hot sauce. I hope I've gotten your interest. There are high expectations and you'll work hard, but that's a good thing. Lab is fun. The reward is that you experience your comfort level in the lab improve as you become more independent with your experimental work. Finally, and most importantly, I promise you a supportive environment. Whether you're trying to understand lecture calculations or figure out how to troubleshoot something in the lab, if you have any questions, please send me an email, and I look forward to seeing you soon.